Hey, boys and girls. So today we're going to focus on subtraction. Last time we did addition. Now we're going to look at some subtraction problems. One of the things about subtraction, just like addition, is there are many different ways to solve subtraction problems. For example, this is 51 minus 26 equals n representing number. Well, here's one strategy on a number line. If you take that big number, the 51, you put it all the way to the right on the number line, and then you count back by breaking the 26 into chunks of 10 or friendly numbers and 6 ones. You count back 10, 41, another 10, 31. So we've gone the 20, and now 30, 29, 28, 27, 26, 25, and you stop at 25, and that's your answer. So that's just one way. That's the removal takeaway method. Then there's also the finding the difference. I personally like the finding the difference method because you get to count forward. And the way to do that is you plot both numbers once again, or you plot the big number once again on the number line here. But you also put the small number on the number line. And then what you're doing is you're starting at the small number, and then you're going to count forward up to the big number. And the answer is going to be all the jumps that you made. So 26, and keep in mind also, we always want to get to friendly numbers. Friendly numbers are your friend, hence the name. So 26, I know 6 and 4 are 10's complements. So I can get to 30 by adding 4. And now I have to go from 30 up to 51. Well, from 30 plus 20, you get to 50. And then just one more jump to get to 51. So we can count our chunks of 10s, the 20, and then our ones, a 4 and a 1. So 4 plus 1 is 5, 25. Okay, so the next strategy is finding the difference, jumping from big to small. So it's essentially the exact same thing what we did, only instead of counting forward from 26 up to 51, you're counting backwards from 51 down to 26. I'm not the hugest fan of this strategy simply because the whole reason why I'm plotting them both on there is so I get to count forward instead of backward. So the next one, here's some triple digit examples. This is the removal takeaway, and that's when you take the big number and you put it all the way to the right on the number line where it should go. And then we're going to take 347 away in 3 separate chunks. We're going to take the 300 away, so we're at 562. So 462, 362, 262. In fact, when I go back, or when I show hundreds on the number line, what I do is I go 462, 362, 262, and I make mountains, like pointy mountains, and each one of these peaks is 100. So now we're at 262. And now we're going to take away the 40. So I know 60 minus 40 equals 20. So 262 becomes 222. And then we're going to take away 7. So we're going to take away the 2 to get you to 220. And then the rest of the 7, the 5, to get you to 215. And your answer is the number that you land on. And then once again, finding the difference. Now, this is a strategy, probably my all-time favorite. It blew my mind when I first learned it. What you do is you plot your big number and your small number. So here's my big number, 562, and my small number, 347. And then there is a way to tweak your problem to make it an easier problem. So you're going to actually change the problem to a different problem, but the way that you change it will make sure that the answer to the different, easier problem is the exact same. And all you do, it's very similar to the give and take strategy from addition, only your goal is to make the small number, not the big number to the left of the subtraction side, but the small number, a friendly number. So what I do is I'm going to first make 347 turn into a friendly number by just adding 3. So I'm going to add 3 to this side.
But if I want my difference to remain the same difference, which you do because you want your answer to be correct, you don't want to just add 3 here and then subtract, and then all of a sudden your answer is going to be off. So whatever you do to the one number, the small number, you also need to do it to the big number. So 562 changes to 565. So really what you're doing is you're finding the difference between these two as opposed to these two. So you change your problem to 565 minus 350. And that is much easier than having to think about 562 minus 347. So when you look at the tens and the ones here, like the 5 minus the 0 is a 5 in the ones place. You got the 6 minus the 5 is a 1. And then the 5 minus 3 is 2. Okay? Another way you could look at this, you could, once you get to this point, 565 minus 350, is you could just take the constant difference a step further and even make it simpler. So you might, okay, now we really want this to be an ultra friendly number in the hundreds. Okay. Well, we could either add 50 or subtract 50 because we're right there smack dab in the middle of the 300s. Now, if I add 50, then I'm going to have to add 50 to this side. But if I subtract 50, I can take away 50. If I added 50 here and I added 50 here, I'm going to have to go past the 600 century mark. But if I take 50 away from here and I take 50 away from here, we're keeping our difference constant, but we're changing the problem. So now it becomes 515 minus 300. Okay, and that's even easier than before. 515 minus 300, now all we have to do is worry about taking 300s away from 500. So now it becomes 215. Now, I know that's probably confusing to you. I'm going to give you some examples. Only this time we're going to show different strategies. So 78 minus 22. If we did 78 minus 22 on a number line, you put 78 here, and you minus 22. So 68, 58. Those are my two tens, right? So I minus my 28, 58. And now I got to take away, I took my 20 away, now I got to take my 2. So 58, 57, 56. So the answer is 56. Because I took my 22 away and I landed on 56. Okay? Then there's just regular old subtraction. For this particular problem, I think the best method, to be honest with you, is simply stacking. You don't have to worry about trading because the big number's on top, 78, and also in every place value, the large number is on top. 8's bigger than 2, 7 is bigger than 2. So 8 minus 2 is 6, 7 minus 2 is 5. And then there's another way to do it, like we were talking about constant difference on a number line. If I tweak 22, if I just took 2 away from 22, and that means I would also have to take 2 away from 78. The reason I chose to take 2 away from 22 is because I wanted to get this a friendly number. But if you do it to one side, for subtraction, you also have to do it to the other. So I'm changing my problem. So it becomes 76 minus 20. So if this was on the number line, if I have a 20 and I'm trying to get up to 76, it would take me a jump of 56. So your difference is 56. So that one was a little bit easier. So it kind of loans itself better to this one since this is larger. But the ones that are best for constant difference, especially, are the ones where you're going to have to trade, and trading can be confusing. Like this one, 84 minus 17. So if I was going to just solve it stacking, 4 minus 7 can't do. There's more on the floor, so you need to go next door and get 10 more. So that becomes a 7, and that's a 14. So 14 minus 7 is 7. 7 minus 1 is 6. So we know our answer is 67. Okay, another way on a number line, just like the standard way, would be
putting the 84, the big number over here, and then jumping back 17. So jumping back a 10 would give you to 74. And then we got to take 7 away. So we're going to jump back a 4 to get you to the friendly number. So far, we've jumped back 10 and 4. That's only 14. We have to do 3 more. And I know my 10's complement, 3 and 7 have the same haircut. So 3 and 7, if I jump back 3, I'm at 67 because 3 and 7 make a 10. And now we have completed our 17. We've jumped back 17 and we've landed on 67. Okay. Now this is where you really want to focus. 84 minus 17. If we do constant difference, okay? So what you do is you look for the small number and you see how can you tweak this small number to make it friendly? And right here, my answer is I'm at 17. If I add 3, I'm at 20. Well, that means if we're doing constant difference, we need to also add 3 to this side. So I've changed my entire problem now. 84 plus 3 is 87. And 17 plus 3 is 20. So what I'm going to do is I'm going to now subtract 20 from 87 or jump from 20 up to 87. So 30, 40, 50, 60, 70, 80. So that's 10, 20, 30, 40, 50, 60, and then a jump of 7. So I've jumped 60 and 7. But the beauty of constant difference is once you've changed this to 87 and change this to 20, you don't even need the number line anymore because you could do 87 minus 20 in your brain. 87 take off 80 take off 20 is 60, and then you're going to leave the ones place alone. So that's what I love about constant difference. We'll try one more. This time we'll do a triple digit. And let me try a different color here. We'll go Spartan green. All right. So 347 minus 69. Well, if we were stacking this, 7 minus 9, there's more on the floor. So you need to go next door and get 10 more. So this changes to a 3. This changes to a 17. So now you could do 17 minus 9. Well, I know 17 minus 10 is 7. So 17 minus 9 must be one more than that. It's 8. And then 3 minus 6 you cannot do. So this needs to go next door. It changes it to a 2. That's a 13 minus 6. Well, 12 minus 6 is 6. So 13 minus 6 must be one more. It's 7. And then 2 minus nothing is 2. So the answer is 278. But look at all that trading I had to do, the crossing out and everything. And you have to keep track of a lot of stuff when you're doing this, which this is a great solid method, but there's other faster methods. This time I'm not even going to do the count back, the 347 counting back to 69. I'm not even going to do this on the number line. I'm just going to do constant difference. First things first, I want this number to be changed to a friendly number. So my first thing I'm going to do is 69. It's right on the brink of being 70. So I'm going to add 1 to this side, and I'm going to add 1 to this side. So now we're talking 348 minus 70. Now, it's triple digit. That doesn't really help me that much because even if I stack this one or if I put it on the number line and we're still a ways away, if I stacked it, we're still going to have to trade. So now what I want to do is I want to go a step further and I want to get to an ultra friendly number. That means like a century mark. So I'm at 70. How do I get to the next century mark, which would be 100? Well, what I would do this time, let me erase this here real quick. Oh no, I erased too much. So I was at 70, and if I add 30 on, now I'm at 100. Let me add 30 to the other side, and watch how easy this problem becomes. So 348 now becomes 378. And then the 70 becomes 100. 378 minus 100 equals 278. I didn't have to do any of this trading or anything. I just tweaked. I ended up tweaking this twice. I tweaked the ones place to get it to a friendly 10. Then I added on another 30 to get it to a friendly century mark, ultra friendly number. It's all about making this one friendly, and then whatever you do to one side, you have to do the exact same, which is different than addition. Addition, you have to, if you add one to one side, you minus one from the other. Subtraction, if you add one to one side, you add one to the other. If you subtract one from one side, you subtract one from the other. So good luck. Come back and visit this video as many times as you'd like. And hopefully this has been helpful.